We're in Module 13, and we started it the other day, and we were graphing, and we were just talking about two formulas, the distance and the midpoint. Well, today we're actually going to get to graph some lines. So in Module 13b, we're going to talk about graphing linear equations. So let's go to our notes. Okay, before we even start graphing an equation, we've got to go through some basic vocabulary. The words of graphing have not changed since Algebra 1. So you're going to hear the same words you heard back then. So let's just go through this and make sure we're all on the same page. First of all, the thing that you graph on has a name. It's called the Cartesian coordinate system. And it was developed by a French mathematician, René Descartes. So you can see Descartes is his last name, and we use his name when we say the Cartesian coordinate system. And what you know that is as the x and y axis. He is the first mathematician that visually took what you were solving on paper and making a picture of it. And what René said is if you take two number lines and draw them perpendicular to each other, you will have the Cartesian coordinate system. And we know the number line that goes across left to right is called the x-axis, and the number line that goes up and down is called the y-axis. We also know where those two number lines meet in the center is called the origin. We then know that when you take those two number lines and you intersect them, they make four boxes or four quadrants. And basically our job on this system is to plot points. And a point is called an ordered pair because it has two values. It has an x value and y value. So if you look here at the PowerPoint notes, you can see there's your Cartesian coordinate system. You drew the horizontal number line, the x-axis, the vertical number line, the y-axis. The point where they meet is called the origin. And then you have the four quadrants. And the quadrants just help us locate. So if I said to everybody look in quadrant 2, everybody would look in the same spot. Our goal is to draw pictures of equations. So what we're going to have to do on this system is plot points and then connect the dots like we would do as a little child. Okay? So what we're going to be doing is drawing equations. Now, the first thing we need to start with is which equation are we going to draw first? When we started out college algebra, we're talking about linear equations. And linear is a Latin word, and in that word is the word line. And that's what linear equations draw to be. They draw pictures of lines. So what we're going to do today is we're going to be drawing lines. Now, I want everybody to come over here. Let's look at me for a minute. Okay, if our goal is to draw lines, then what you need to understand is you can only form three types of lines. If you hold your hands out this way, from left to right, you're making a line. It is a horizontal line. If you put your hands up and down like this, you are making a vertical line. And if you hold your hands slanted and slanted, you're making a diagonal line. So in this module, we're going to be graphing linear equations. Linear equations make lines. There are only three types of lines I could ask you to draw: horizontal, vertical, diagonal. Okay, let's go back to the notes. So what first thing you're going to need to do is memorize some facts. And it's very simple. The first fact is you always know what you're going to draw by looking at the equation. The equation is going to tell you whether the line is only going to touch the x-axis, the y-axis, or both axes. So if you look here at the notes, you will know you're drawing a horizontal line because it just has the letter y in it. So you've got to memorize the letter y makes a horizontal line. A vertical line will only have in the equation the letter x. So if you see in your equation just the letter x, you're going to draw a vertical line. And a diagonal line will always touch both axes. It has both variables. So if you look, a diagonal line equation will have a y and an x. So that's the most important thing. Now, why is that important? Because look here. I have up here 7 equations. What I want you to notice is you should know what you're drawing by just looking at the variables. So if you look here, which equations just have the letter y in them? Well, that's equation A. A has a y in it. That means that's going to be a picture of a horizontal line. Which equations just have a letter x? Well, that's equation B and equation E. They just have a letter X in them. So those would be vertical lines. Equation C, D, and G have an X and a Y. It doesn't matter if they're on the left side or right side. Equations C, D, and G have the letter X and the letter Y. That means those would be pictures of diagonal lines. Now, the only equation I skipped was F, because equation F doesn't just have an X, it has an f of X. And we already discussed that. That is function notation. And what you're to do with function notation is every time you see it, you're to cross it out. And what variable are you supposed to put? That's right, you're supposed to put the letter Y. So I would rewrite that equation not as f of X equals -1, but Y equals -1. And if it just has the letter Y, it's going to be what type of line? That's right, it's going to be horizontal. So it's very important that you understand, before you ever go to the graph paper, you should know what you're drawing by looking at the equation. The letter in it, the variable in it, will tell you what type of line to draw. Now, there are 3 ways we can graph a diagonal line. And this is important. We're going to build from how you learned it first to the quicker or more efficient method. Back in elementary school, you should have learned to set up a t-table. And in that t-table, you'll have x values and y values. And that's what you'll use to graph a line. So let me show you an example. This is the first example we want to graph. The equation up on the top is 5x minus 2y equals 10. But then you see a t-table given. And a t-table gets its name because it has a letter T. And you're given some x values and some y values. So what I'm about to show you is how you use a t-table to graph an equation. Let's go to the whiteboard. Okay, so first of all, what I want you to notice is, oh, I didn't get to the whiteboard. I'm sorry. Okay, guys, here I am. So what I want you to notice is I gave you this equation, 5x minus 2y equals 10. Before you ever touch the paper, you should make a decision. Is it horizontal, vertical, or diagonal? It has the letter X. It has the letter Y. That means this picture is going to touch both the X and the Y axis. It's got to be a diagonal line. So I'm going to write myself that note. It's going to be diagonal. Now, the easiest way that you all learned to graph a diagonal line is to plot points. But to plot points, you need an X value and a Y value. Well, in a t-table, I start you off by giving you some of the values. So we're going to have to find the missing part. So if you look here, I'm giving you 5. 5 represents Y. Well, if you know Y is 5, how would you get the number for X? What would you do? Very good. You would take this number and substitute it in the equation. So now I want you to make a connection. Do you understand why we had to learn to solve equations first? Because you got to know how to work an equation before you can graph it, draw a picture. So I'm going to write this equation. 5x minus 2, but instead of leaving y, I'm going to replace it with 5, equals 10. Now I'm going to solve it. So I'll do my multiplying. 5x minus 10 equals 10. It's a simple linear equation to solve. I'll add 10. 5x equals 20. I'll divide by 5, and I'll get x is 4. And I'll put that in my t-table. What you've done is you've now made an ordered pair. You have an x value and a y value. Now you can go to your graph paper and plot that. So I'll go to x is 4. Let me label my axes here for you. So I'll go to x is 4, and I'll go to y is 5, and there's my first point to plot. But I can't draw a line yet because plotting one point doesn't guarantee which line it is. This line could be horizontal, this line could be vertical, this line could be diagonal. So I need some more information. So I go to my t-table. Here's my next piece of information. They give me a 1, but 1 is in the column for x. So I'm going to substitute in for 1 where the x is. So I'm using the same equation because that's what I want to draw a picture of, that equation. So to write the same equation, 5x minus 2y equals 10. But now I'm going to substitute x as 1. So I'm going to write 5 times 1 minus 2y equals 10. I'm going to multiply 5 minus 2y equals 10. And now I'm going to solve. I'm going to subtract 5. Negative 2y equals 10 minus 5 is 5. I'm going to divide by negative 2. And now you have a choice. You could either write that as an improper fraction, negative 5 halves, or you could divide it out and make that decimal that terminates, that stops. Negative 5 divided by 2 is negative 2 and 5/10. And as you all know, to graph, it's much easier to work with decimals to find out what they are on the number line versus the fractions. So now I can go plot that point. I can go to x is 1, and I can go to y is negative 2.5, which would be somewhere in between negative 2 and negative 3. Now, I have 2 points. Can I connect them? Sure I can. And if I connect them, I would make a diagonal line. And that's the minimal number of points you need. It's just 2. But because our t-table gives us another value, we have to continue. So on our t-table, I have another number. It's negative 5. It's going to replace y. So we're going to do the process over. We're going to write 5x minus 2. X now is negative 5 equals 10. We'll multiply, so we'll get 5x, a negative times a negative is a positive 10, equals 10. We'll subtract our 10. We'll get 5x equals 10 minus 10 is 0. We'll divide by 5. And nothing divided among 5 people. If I have nothing and I divide it among 5 of you, you all get nothing. So that's a 0. So now I'm going to go plot that third ordered pair, that third point. 0, negative 5 means I'm at the origin. I don't move left or right because my x value is 0. My y value says move down 5. And now I have enough information for sure, and I should be using a straight edge, and I apologize. I don't have a straight edge today. And that would connect and make a nice diagonal line. So René Descartes, this French mathematician, wanted you to make a connection. Every equation on paper makes a picture. Because this is a linear equation, x to the first, y to the first, linear equations make pictures of lines. Because this equation has both an x and a y, it will make a diagonal line. And everybody look, this line touches the x-axis. This line touches the y-axis. That's why a diagonal line has both variables in its equation. All right, let's go back to our notes.